Hi students, welcome back to the class. This is the third part of the chapter, Applications of Derivative. In this part, we will be discussing about tangents and normal. In the previous classes, we already explained what is the geometrical meaning of derivative. Do you remember that? What is the geometrical meaning of derivative? So geometrically, the derivative means slope. Slope of the tangent of a curve at any point. So geometrically, derivative means slope of the tangent to the curve at any point. Suppose we have a curve y equal to x square. You know y equal to x square is a parabola. You already know that y equal to x square is a parabola. Let 1, 1 be any point on this curve. Let 1, 1 be any point on this curve. We are interested in finding the slope of the tangent at this point 1, 1. Let's see. So let's draw a tangent at this point. Right. Okay. So we are interested to find the slope of the tangent at this point. So the equation of curve is y equal to x square. As we said, in order to find the slope of this tangent at this point, we need to differentiate. So let's differentiate this curve. dy by dx, derivative of y is dy by dx equal to 2x. So we need to find the slope of the tangent at the point 1, 1. Okay. So slope of the tangent at 1, 1. Let's write it. Slope at 1, 1 is equal to, we need to substitute this point at the place of dy by dx. To get the slope of the tangent, we need to substitute the point at the place of dy by dx of the curve. So this is dy by dx, 2x is dy by dx. So we have to substitute this point. So this is 2 into x, means 2 into x coordinate. So 2 into the x coordinate is 1. So 2 into 1, which is equal to 2. Since there is no place to substitute the y coordinate, it's okay. If there is place to substitute y coordinate, you can substitute y coordinate also. So 2 into 1, which is equal to 2. So 2 is the slope of this tangent. Okay, slope of this tangent at the point 1, 1 to the curve y equal to x square is equal to 2. The point varies, like if there is another point, like the coordinate may be 2, 4. Suppose we have another point 2, 4. In order to find the slope of tangent at this point, the slope of tangent varies, right? The tangent is different at this point. Okay, so in order to find the slope of this tangent, we need to substitute x equal to 2. So you will get 4 as the slope of tangent. So the slope of the tangent varies from point to point, right? The slope varies from point to point. So that's why this is a curve. If the slope is throughout same, then this will be a line. For a line, slope at any point are same, right? Slope at this point or slope at this point, at all the points, the slope will be same. That is why this is a line. And for a curve, the slope of tangent at this point, this point, this point, so this all the slope will be different. That is why this curve, in the curve, this slope varies from point to point, right? So this is how we will find the slope of the tangent. Let's see how will be the questions asked from this topic. What all kind of questions may be asked from this point? The only concept to learn is to find the slope of tangent. How will you find the slope of tangent? You will differentiate and substitute the point. You will get the slope of tangent. Let's see how will be the question asked from this concept, right? So the questions may like this, you are provided the equation of curve and a point on the curve. So an equation of curve is given. Let's say an example. Let y equal to x square. I am taking the same example, y equal to x square. The equation of the curve is given and the point on the curve. Let's 3, 9 be the point on the curve. 3, if x equal to 3, then y is the square of x. That means y equal to 9. And 3, 9 is a point on the curve. We have to find the slope of the tangent at this point. So what you have to do is to differentiate dy by dx, which is equal to 2x, and substitute this point. You will get 2 into 3, which is equal to 6. So 6 is the slope of the tangent at the point 3, 9. So this is the direct question. This may ask for just 1 mark. Okay, so this is a 1 mark question. Let's see what is the next type. So equation of the curve is given. This is ditto. So equation of the curve is given and the point of the curve is given. So equation and the point of the curve is given. So what you have to find is find the equation of the tangent at that point. So equation of the curve and a point is given. Right. So equation of the curve. Let's take an example. Y equal to x square is the equation of the curve and a point is provided which is 3, 9. We have to find the equation of tangent at this point. Like this is the equation of curve and here we have a point 3, 9 and we have to find the equation of this tangent. This is 3, 9. You have to find the equation of this line. In order to find the equation of line, you need two things. You need the point and slope. You need a point on the line and you need a slope of the line to find the equation of line. How will you find the equation of line? That you have learned in class 11, right? Class 11 in straight lines. Point slope form. Y minus y1 is equal to m into x minus x1, where x1, y1 is a point and m is the slope. So point which is already given in the question 3, 9, you just need to find the slope that you already know how to find the slope. So dy by dx equal to 2x. So slope is equal to, slope means slope of the tangent, right? Slope of the tangent is equal to, I am repeating this as slope of the tangent because this is the concept tangents and normals. The question may ask about normals too, but first we will complete about tangents, then we will go to normals. Okay, so slope of tangent is dy by dx. At this point, slope of tangent is equal to 6. Okay, now you need to find the equation of this tangent line. Y minus y1 equal to m into x minus x1. This is the formula we use to find the equation of tangent. This is point slope form. So y minus y1 means y minus y1, y coordinate is 3. So let's write it over here. Y minus 3 is equal to 6 into x minus 9. So y minus 3 equal to 6 into x minus 9. You just need to simplify that. Okay, so y minus 3 is equal to 6x minus 18. On simplifying this, 6x minus y minus 18 and sorry, y minus not y minus 3, y minus 9 is equal to 6 into x minus 3. Okay, so y minus 3 equal to 6 into x minus 18. So 6x minus y, so here will be 9. So 6x minus y minus 9 equal to 0. So this is the equation. Okay, 6x minus y minus 9 equal to 0. Okay, so let's check out the fourth type of question. Okay, so we have done this, we have to check this. Okay, so fourth type of question in which what is given, just read that. So in the next type, equation of the curve will be given and slope of the tangent will be given. Okay, so equation of the curve and slope of tangent is given. You have to find the point of contact of the curve. So here equation of the curve is given and the slope of tangent is also given. So you need to find the point at which the slope of the tangent is equal to that value. Slope of the tangent will be given. Okay, so let's do an example. Suppose we have an equation of the curve y equal to x square and slope of tangent slope is equal to 6. We have to find the point at which the slope will be equal to 6. So we have a curve y equal to x square and a tangent whose slope is 6. So at what point the slope will be equal to 6? So what I have to do is differentiate it, dy by dx equal to 2x. Substitute slope at the place of dy by dx. So we have 6 is equal to 2x. So x is equal to 3. So this is the x coordinate of the point of contact. So the point of contact means where the tangent and curve meets. This is the point of contact. So x equal to 3 is the point of contact, the point which we have to find, x equal to 3. So y is equal to, the y coordinate will be equal to, since y equal to x square, y coordinate will be equal to 9. So 3, 9 is the point at which the slope of the tangent is equal to 6. This is how we will find the point if the slope of the tangent is provided. We need to differentiate the curve, substitute the slope at the place of dy by dx and solve to find any question. Here we got x coordinate, sometimes we will get y coordinate, then we can find x coordinate. So if we got x coordinate, we can find y coordinate also. Okay, this is how we'll find the point. So next type is equation of the curve and slope of tangent will be given. We have to find the equation of the tangent. So equation of curve and slope of tangent will be given. We have to find the equation of tangent. Okay, same. Y equal to x square, equation of curve is given, slope is equal to 6. So equation of curve is given, slope is equal to 6. Slope of tangent is given, you need to find the equation of tangent. So in order to find the equation of tangent, you need two things, point and slope. Slope is given, you first find the point, then you can find the equation of tangent. So in order to find the point, we just need to differentiate. Y equal to 2x, substitute the slope at the place of dy by dx. 6 is equal to 2x, where x equal to 3, then y will be equal to 9. So 3, 9 is the point. Then what you have to do next is using point slope form, just find the equation. So using point slope form, y minus 9 is equal to slope 6 into x minus 3. Then simplify and you'll get the same equation of line, because I am taking the same example again and again to make it simpler, right? So you get the same equation of line which we found earlier. Okay. Let's rewind it once again. And equation of the curve will be given. So this is given, the equation is given, a point is given, a point on this curve is given. You just need to find the slope of this tangent. So how will you do, this point is given, okay, the equation of curve and the point is given. You will just differentiate this curve, okay, you will just differentiate this curve, you will form dy by dx, you substitute this point at the place of x and y, you will get the slope of this tangent. Then you have to find the equation of this tangent, you will use point slope form. Already point is given, you just found the slope and you will use point slope form, y minus y1 equal to m into x minus x1. And in the next section, equation of curve will be given, slope of this tangent will be given. You need to find this point. Then what you have to do is differentiate and substitute the value of slope. Okay, substitute the value of slope of tangent at the place of dy by dx. So I am repeating it again and again. You have to substitute slope of tangent at the place of dy by dx, because it may be like it is given that a slope of line which is perpendicular to this tangent. Suppose the slope of line which is perpendicular to the tangent, this is given, slope of this line is given. So you can't substitute the slope of this line at the place of dy by dx. You need to find the slope of the tangent first. If this line is slope of this line is given, suppose the slope of this line is a by p. The slope of the line which is perpendicular to the slope of the tangent which is perpendicular to this line is minus b by a. So you need to substitute that slope of tangent at the place of dy by dx. Okay. So you find the slope of tangent and substitute at the place of dy by dx. Solve to find the slope. Find the point on this. To find this point. And if you found this point, you can also find the equation of tangent if it is asked in the question by point slope form. Okay, so mainly the questions are like this. Next, this concept is tangents and normal. So you need to know about normal. What is normal? So if this is a tangent to the curve at this point, a line which is perpendicular to this tangent through the point of contact, this line is normal. Okay, not just any line, a line which is perpendicular to the tangent through the point of contact. This is normal. So in order to find the slope of normal, you first need to find the slope of tangent and take the negative reciprocal to find the slope of normal. Okay, because tangent and normal are perpendicular to each other, product of the slope will be -1. So in order to find the slope of the normal, you just take the negative reciprocal, you will get the slope of the normal. Okay, and if you got the slope of the normal, you can find the equation of the normal by point slope form. The point is already given. You just form the slope and you can find the slope of the normal. Okay, so finding the slope of normal or equation of normal is not a big thing if you already know how to find the slope of the tangent. Okay, so let's see how will be the question. So let's do some problems from our NCERT textbook. Okay, so take your NCERT textbook exercise 6.3, and let's do the questions. Okay. So take the second question. Find the slope of tangent to the curve y equal x minus 1 by x minus 2 or x not equal to x equal to 10. Okay, so equation of curve is given y equal to x minus 1 by x minus 2, x is not equal to 2. This is the condition because it makes the denominator 0. You have to find the slope of the tangent at x equal to 10. Okay, so first you differentiate this. Dy by dx equal to, you have to use the quotient rule, right? So derivative of x minus 1, which is 1 into x minus 2 minus of, I am finding dy by dx. I am differentiating this. Okay, so by quotient rule. So derivative of x minus 2 is 1 into x minus 1 is x minus 1 itself divided by x minus 2 whole square, which makes this x and x will be cancelled, minus 2 plus 1. Minus 1 by x minus 1 whole square, this is dy by dx. Now we have to find the slope at the x equal to 10. So you can substitute x equal to 10. The slope at x equal to 10 is negative 1 by 10 minus 2, which 10 minus 2 whole square, that is negative 1 by 64. 10 minus 2 is 8, 8 square is 64. So negative 1 by 64 is the answer of the second question. Let's move to the next question. Okay. So now let's do the seventh question in NCERT. The question is, find point at which tangent to the curve y equal x cube minus 3x square minus 9x plus 7 is parallel to x-axis. Okay, so you have to find the point on this curve at which the tangent is parallel to x-axis. Suppose the curve is like this. Okay, let us assume the curve to be like this. You have to find the point on this curve at which the tangent is parallel to x-axis. Okay, so tangent parallel to x-axis may be like this. Okay, so the tangent is parallel to the x-axis. That is, if the tangent is parallel to x-axis, the slope of the tangent will be equal to 0. Because a line parallel to x-axis means horizontal line. Slope of horizontal line is always equal to 0. So slope of tangent is equal to 0. So here slope is provided indirectly as 0. We need to find the point. So what you have to do is, this is the third type of problem, right? What you have to do is differentiate this. So differentiating, you will get 3x square minus 6x minus 6 is equal to 0. This is the equation, correct? X cube minus 3x square minus, here it is 9x, I'm sorry, here it is 9x and here it is 9x and here it is plus 7. Okay, so dy by dx equal to minus 3x square minus 6x minus 9. So this is the dy by dx. We will substitute slope at the place of dy by dx. So 0 is equal to 3x square minus 6x minus 9. We have to solve this in order to find the x coordinate. So how will we find it? How will we solve it? We will just divide this equation with 3. You will get x square minus 2x minus 3 is equal to 0. I just divided this equation with 3. Okay, now we found a quadratic equation. We have to solve this. Factorize this like x minus 3 into x plus 1 equal to 0. X minus 3 into x plus 1. You get the same thing. Okay, so x is equal to 3 or negative 1. So x equal to 3 or x equal to negative 1 is the x coordinate of the point. So we need to find the y coordinate. So we have y equal to this, y equal to x cube minus. So if x equal to 3, then y will be equal to 3 cube minus 3 into 3 square minus 9 into 3 plus 7, which will be equal to negative 20. And if x is equal to minus 1, y is equal to minus 1 cube. 3 into this is 3 minus 1 is 4, which will be equal to 12. I don't know if I have made any mistake, calculation mistakes. If I have made any mistake, you just correct me. You can comment down below. Okay, or you can send me you can send me the WhatsApp that you have made a mistake. So 3 in 3 comma negative 20 and minus 1 comma 12 are the points on this curve at which the tangent is parallel to x-axis. Okay, let's do next question. So now read question number 11. Find the equation of all lines having slope 2 which are tangent to the curve y is equal to 1 by x minus 3. So we have to find the equation of tangent whose slope is 2 and the equation of curve is 1 by x minus 3. So slope is given. So we have to substitute the slope at the place of dy by dx. So dy by dx equal to derivative of 1 by x minus 3 is negative 1 by x minus 3 whole square, right? Since dy by dx of 1 by x is negative 1 by x square. That's why dy by dx equal to negative 1 by x minus 3 whole square. So let's substitute slope of tangent at the place of dy by dx. That means 2 is equal to minus 1 by x minus 3 whole square. We have to solve this. Okay, taking x minus 3 whole square here and 2 here. Let us swap this. Okay. So x minus 3 whole square is equal to negative 1 by 2. So in order to find x minus 3 is equal to under root of negative 1 by 2. You know, finding the square root of a negative number is not possible in real numbers. So this is not real, or there is no real solutions. Okay, so we can't solve this in real number. That means a slope with slope 2, a tangent with slope 2 is not possible to this curve. Okay, no tangent is possible with slope 2. In fact, no tangent is possible with a positive slope. Not only the value 2, any positive slope is not possible. If here it is a negative value, both negative will be cancelled and we can find the answer. Okay, so here no tangent is possible with the given slope 2. Maybe the curve is like, since this is 1 by x minus 3, so maybe the curve is like this. Okay, the curve is like this. The tangent will be always makes an angle which is obtuse. Okay, so it may make the only tangent with negative slope is possible for this curve. A tangent with positive slope is not possible for this curve. Okay, so this is the answer. No tangent is possible with the slope 2 to the given curve. Okay, let's do next question. Okay, read question number 10. Okay, question number 10. So question number 10 is same type. Find equation of all line with slope negative 1 to the curve 1 by y equal to 1 by x minus 1. So equation of curve is 1 by x minus 1, slope is negative 1. I have to find equation of tangent. First we find the point, then we will find the equation of tangent. Okay, so dy by dx equal to minus 1 by x minus 1 whole square. Okay, substitute slope is equal to negative 1, slope of tangent is equal to negative 1. So substituting negative 1 is equal to negative 1 by x minus 1 whole square, cancelling both this negative. So x minus 1 whole square equal to 1. So x minus 1 is equal to plus or minus 1 under root of 1, which is plus or minus 1. So x is equal to, taking negative 1 to this side, so x is equal to 1 plus 1 equal to 2, or x equal to minus 1 plus 1 equal to 0. Minus 1 plus 1 equal to 0. So x coordinate is 2 or 0. We'll find y coordinate. Y is equal to 1 by x minus 1 means 1 by 2 minus 1, which is equal to 1, or y is equal to 1 by, substituting 0 here, y equal to minus 1. So 2 comma 1, this x is equal to 2 and y equal to 1, 2 comma 1 and 0 comma negative 1. Okay, maybe the points. The slope is equal to negative 1. So we need to find the equation of all lines with this slope negative 1. So we'll find the equation of line with this slope negative 1 and with this point, and then we'll find the equation of line with this slope and this point. Okay, so y minus 1, I am taking this point now. This time I'll take this point. So y minus 1 is equal to m into the slope into x minus 2. Y minus y1 equal to m into x minus x1. So on simplifying this, you will get for the answer of the first. You will get the slope equation of one line. Then you can take this point. So y, you have to simplify this. Okay. So I think that you will do alone. Y plus 1 is equal to slope negative 1 into x minus 0. So simplify this, you will get the equation of next line. Okay, we will move to the next question. Okay. Next we will do question number 14, the first part of it. equation of curve y is equal to x raised to 4 minus 6x cube plus 13x square minus 10x plus 5. We have to find the equation of tangent and normal at the point 0, 5. So you need to find the equation of tangent and equation of normal at the point 0, 5. Since the point is given, we need to find the slope of the tangent first. Okay, so what is the slope of tangent? Let's differentiate this. So differentiating this, dy by dx equal to 4x cube minus 18x square plus 26x minus 10. Okay, so slope of tangent at 0, 5. Okay, slope you have to substitute x equal to 0 at the place of dy by dx. So slope is equal to, substituting 0, you will get all these terms will be cancelled, you will get negative 10. So negative 10 is the slope of the tangent. Okay, so slope of tangent is negative 10. So in order to find this equation of tangent, you just use point slope form. Y minus y1, that is y minus 5 is equal to m into, that means negative 10 into x minus 0. On simplifying this, you will get equation of tangent. Okay, now the equation of normal, first we will find slope of normal. Slope of normal. Okay, slope of normal will be negative reciprocal of the slope of tangent, which is negative 10. So negative 1 by negative 10, which is equal to 1 by 10. 1 by 10 is the slope of normal. Now we will find the equation of normal with the slope and the same point 0, 5. So y minus 5 is equal to 1 by 10 into x minus 0. Take 10 to this side, that is 10 into y minus 5 is equal to x. Simplify this to find the equation of normal. This is done. Okay. Now we will do the fifth part of the same question, question number 14. Okay, fifth part where x equal to cos t and y equal to sin t. Okay. So read the fifth part of that. So this time the equation of curve is provided in parametric form. You remember parametric form, which we have discussed while taking the chapter continuity and differentiability, derivatives of the functions in parametric form. The function is given in parametric form, x equal to cos t, y is equal to sin t, and we have to find equation of tangent and normal when t is equal to pi by 4. So first let's find dy by dx. So how to find dy by dx? We will find dy by dt, dx by dt, then we will divide, we will find dy by dx. Okay. So dy by dt, derivative of y with respect to t, dy by dt is equal to cos t, dx by dt, derivative of x with respect to t is negative sin t. Then dy by dx is equal to dy by dt over dx by dt, which is cos t over minus sin t. This is negative cot t. So negative cot t is the slope of tangent. At t is equal to pi by 4. Okay, slope of tangent. T means tangent. This is a shortcut. Okay, short form of tangent. So slope of tangent at t equal to pi by 4 will be equal to negative cot pi by 4 is equal to negative 1. So negative 1 is the slope of tangent. Okay, let's find the slope of normal also. So slope of normal is negative reciprocal of this. So slope of normal is negative 1 by negative 1, which is equal to 1. So we found the slope of tangent and slope of normal. Now we will find the equation of tangent and equation of normal. So in order to find equation of tangent, we need slope and the point. Since slope is given negative 1 and the point is given, the parameter of the point is given, t is equal to pi by 4 is the value of the parameter. Now you have to find the coordinate of the point. See here, x is equal to cos t and t is equal to pi by 4. We need to find the point where the value of the parameter is pi by 4. That means x coordinate is equal to cos pi by 4 is 1 by root 2 and y coordinate is equal to sin pi by 4, which is also equal to 1 by root 2. So the point is 1 by root 2 comma 1 by root 2. So it is done. We found the point. Now we will find the equation of tangent and equation of normal. So equation of tangent will be y minus y1, which is 1 by root 2, is equal to m into, that means negative 1. Slope is negative 1, right? For tangent, slope is negative 1. Negative 1 into x minus 1 by root 2. Okay, simplify this, you will get the equation of tangent, and I think it is x plus y is equal to root 2. If you simplify, you will get it as x plus y is equal to root 2. This is the equation of tangent. Right? Minus is taking this negative 1 by root 2, taking that side. Okay, you will get x plus y equal to root 2. Equation of tangent. Equation of tangent. Let's find equation of normal. Equation of normal, again, y minus 1 by root 2 is equal to, this time the slope will be equal to 1, since slope of normal is 1. So y minus 1 by root 2 equal to x minus 1 by root 2. Cancelling this 1 by root 2 from both sides, you will get y equal to x. This will be equation of normal. Okay, so we found equation of tangent and equation of normal. Okay, and if you remember, this is actually x equal to cos t and y equal to sin t, means this is actually the equation of a circle, right? Since x square plus y square, x square plus y square will be equal to cos square t plus sin square t. That will be equal to 1. That means x square plus y square equal to 1 means this is a unit circle. Okay, it's a circle with radius 1 unit. Okay, this is the equation of the, this is the circle. Okay, of which whose equation is this. A t equal to pi by 4 means the angle, this is the angle t. So this is equal to pi by 4 means this is the point. It represents this point. Okay, so we just found the equation of this tangent. This is actually x plus y equal to root 2. Okay, x plus y equal to root 2 is the equation of this tangent, and equation of normal means a line which is perpendicular to tangent to this through this point of contact. So we found the equation of this normal. This passes through the origin. Okay, the equation of this normal. Equation of this normal is y equal to x. We just found. Okay. So now you read question number 15. So in question number 15, equation of curve is given, and the first part, in the part A, it is said that the tangent is parallel to the line 2x minus y plus 9 equal to 0, and you have to find the equation of tangent. Since tangent is parallel to this line, slope of this line will be equal to tangent. Slope of this line is minus a by b, means that is 2. Slope of this line is 2. Okay, slope of tangent will be same. Slope of tangent is also 2. Just find dy by dx, substitute the slope and find the equation. You have already done the similar questions. Okay, so question number 15, the second part, part B, in where the tangent is perpendicular to this line. So if the tangent is perpendicular to this line, slope of the tangent will be negative reciprocal of the slope of this line. The slope of this line is negative a by b, means negative 15 by 5, which is equal to 3. Okay, 15 by 5, right? 15 by 5 is equal to 3. So slope of tangent will be negative reciprocal of that, means negative 1 by 3. So slope of tangent is negative 1 by 3. You got the slope of tangent. Now we have to find the point and find the equation of line. Okay. Next, question number 17. Read question number 17. Equation of curves y equal to 7x cube plus 11. You have to prove that the tangent at x equal to 2 and x equal to minus 2 are parallel. So you just differentiate. You'll get 21x square. 21 into x square. X square. Okay, so at x equal to 2, the slope of tangent, substituting 2, you will get 21 into 2 square. 21 into 2 square will be, I think it is 84, and next is 21 into negative 2 square. Slope of tangent at negative 2. 21 into negative 2 square, it is also equal to 81, since 2 square and negative 2 square both are same. Okay, so you got that. Now we will do question number 18. Okay, let's do question number 18. Find the points from the curve y equal to x cube at which slope is equal to y coordinate. So we have to find the point on the curve y is equal to x cube where slope of the tangent is equal to y coordinate of the point. Here neither the point or the slope is given. In all the previous question, either slope or the point was given. Here neither the slope or point is given, but a relation is given that the slope is equal to y coordinate. So we have to find a point on this curve y equal to x cube. This is y equal to x cube. We have to find the points at which the slope of the point and the slope of the point is equal to y coordinate of the point. Suppose this is the point h comma k. Let assume that h comma k be the point where slope of the tangent, okay, slope of this tangent is equal to y coordinate. Okay, so let's write, let h comma k be the point, h comma k be point where slope equals y coordinate. Okay, let us assume that h comma k be the point on the curve y equals x cube, where slope is equal to y coordinate. Since point is not given, so let us consider this point to be h comma k. So we can find the slope by differentiating it. So dy by dx equal to 3x square. Since we have considered this as the point, let us substitute h comma k. We will find the slope. So slope is equal to 3 into x square means 3 into h square. So this is the slope. And it is provided that slope is equal to y coordinate. Since y coordinate is k, let us equate it as k is equal to 3x square. Let this be equation number 1. Since slope is equal to y coordinate, k is equal to 3x square. Okay. Now since this point h comma k lies on this curve y is equal to x cube, so there is a relation between k and h. Since y coordinate is equal to cube of x coordinate and h comma k lies on that curve, then k is equal to h cube. Right? K is equal to h cube by substituting h comma k on this curve. Right? Okay. So this, let us consider this be equation number 2. K is equal to 3h square and k is equal to h cube. Equating these two equations, h cube is equal to 3h square. So h cube, let us factorize this or solve this to find the value of h. So h cube minus 3h square is equal to 0. Taking h square in common, h square into h minus 3 equal to 0. Either h is equal to 0 or h is equal to 3. We have just found the x coordinate. 0 or 3. Let's find the y coordinate, which is k. K is equal to h cube. Okay, k is equal to h cube. That means k is equal to 0 or k is equal to h cube is equal to 27. 3 cube, which is 27. Okay, k is equal to h cube means k is equal to 0 cube or k is equal to 3 cube. So 0, 0 and 3, 27 are the points. 3, 27 and 0, 0 are the points at which the slope of the tangent is equal to y coordinate. Let's move the next question. Okay, the very next question, which is for the curve y equal to 4x cube minus 2x raised to find all the point which tangent passes through the origin. Okay, let's move the next question. Next question is question number 19. Find the point on the curve y is equal to 4x cube minus 2x raised to 5 at which the tangent passes through origin. So on the curve y is equal to 4x cube minus 2x raised to 5, suppose this is the curve. We don't know actual diagram of the curve, but we'll simply draw this as the graph of the curve. Okay, suppose this is the equation of curve. We have to find the point at which tangent passes through the origin. Suppose this is a point and the tangent is like this. This is not passes through the origin. Okay, so we have to find the point at which tangent we should pass through the origin. Point may be like this is passing through the origin and it is tangent at this point. Okay. Okay, at this point the tangent is passing through the origin and okay, another tangent. Okay, at this point tangent is passes through the origin. Right. So we have to find point like this where the tangent should pass through the origin for this curve y is equal to 4x cube minus 2x raised to 5. Like the previous question, let us assume that point to be h comma k. Let h comma k be the point at which tangent passes through the origin. Write down. Let h comma k be the point at which tangent passes through the origin. So let's find the slope of the tangent. The slope of the tangent by differentiating. So slope of the tangent is equal to dy by dx is 12x square. On differentiating this, 12x square minus 10x raised to 4. Since we consider the point as h comma k, slope will be equal to 12h square minus 10h raised to 4. Okay, 12h square minus 10h raised to 4. Then the slope is also equal to, since it passes through the origin, one point on the line will be definitely 0, 0 and next is h comma k. So finding slope by the formula y2 minus y1 divided by x2 minus x1. So k minus 0 divided by h minus 0. The slope is equal to k over h. So k upon h. This is also equal to slope. Since both are equal to slope, we can equate this equation together. So k by h is equal to 12h square minus 10h raised to 4, or taking h to this side, okay, this will become 12h cube minus 10h raised to 5. Okay, taking this h to this side. Okay, let this be equation number 1. So like we did on the previous question, since h comma k is point on this curve, we can substitute h comma k on this equation. We will get k is equal to 4h cube minus 2h raised to 5. Let this be equation number 2. Okay, both equation left side is k, right? So we can equate this equation together. That means 12h cube minus 10h raised to 5 should be equal to 4h cube minus 2h raised to 5. Okay, now let us simplify. Let's take all the terms in RHS to the LHS. So 12h cube, taking this 4h cube to left side, 12h cube minus 4h cube, make this 8h cube. Now minus 10h raised to 5, taking minus 2h raised to 5 to this side. So minus 10 plus 2. Okay, minus 10 plus 2 is again minus 8h raised to 5. Did I make a mistake? 12 minus 4 is 8. 10 minus 10 plus 2 is again 8. Okay, let's take 8h cube in common. So taking 8h cube common, what we get is 1 minus h square equal to 0. 8h cube into 1 minus h square equal to 0 means either this h is equal to 0 or 1 minus h square equal to 0. Then h can be plus or minus 1. Okay, since h square minus 1 equal to 0, the value of h may be plus or minus 1. So we have h is equal to 0, h is equal to 1 and h is equal to negative 1 as the x coordinate of this point. Now to find the y coordinate, which is k, the k is the y coordinate, k is equal to 4h cube minus 2h raised to 5. That means substituting 0, we will get if h is equal to 0, we will get 4 into 0, okay, it will be 0. So 0 comma 0 is a point. Now let's substitute h is equal to 1 at the place of h. Okay, let h be h equal to 1. If h is equal to 1, this will be 4 minus 2, which is equal to 2. So when x is 1, y is 2. Let's substitute negative 1. On substituting negative 1, you will get negative 2. Okay, k is equal to, if h is equal to negative 1, we will get k is equal to negative 2. So negative 1 comma negative 2. So these are the points, okay, at which the tangent will pass through the origin. So like in this question and the previous question, the slope or the point, both of them is not given. Just the relation between slope and the point is given. We just found the point on the curve where it is passes through the origin, or in the last question it was the slope was equal to y coordinate. Okay, let's do the next question. So next is question number 23. Prove that the curves x equal to y square and xy equal to k cut at right angles. Okay, to prove that the curve x equal to y square and xy equal to k. Suppose these are the curves. Okay, suppose this is x equal to y square and this curve is x into y equal to k. We need to prove that these curves cut at right angles. This angle between this curve is 90 degree. Okay, angle between this curve means the angle between the tangent at the point of intersection of this curve. Okay, angle between this curve means angle between the tangents at the point of intersection at the point of intersection of these curves. So we need to prove these angles, these lines are at 90 degree. These lines are at 90 degree. Okay, to prove that two lines are perpendicular, what we have to do is we have to prove the product of their slope is negative 1. The product of the slope is negative 1, then the lines are perpendicular to each other. That's we already learned in class 11. So we need to find the slope of these lines. But in order to find the slope, we need the point. Okay, we need the point to find the slope of the line. How will we find the slope? First we will differentiate, then we will substitute point to get the slope of the line. Okay, but the point is not given. But it is said that the curve intersect each other. This is the point of intersection. Okay. So how can we find the point of intersection? We can solve these two equations simultaneously to get the point of intersection. Since x equal to y square and xy equal to k, x equal to y square, x into y equal to k. Equation 1 and equation 2. Okay. Equation 1 and equation 2, xy equal to k. Since x equal to y square, we can substitute y square here. Okay, on solving this two equation together, we can substitute y square here. So this becomes y cube is equal to k, or y equal to cube root of k to the power of 1 by 3. Since x equal to y square, so x coordinate will be equal to square of y coordinate. Square of y coordinate means square of k raised to 1 by 3, which will be k raised to 2 by 3. Thus we got the point as k raised to 2 by 3 comma k raised to 1 by 3. Okay, x coordinate is k raised to 2 by 3 and y coordinate is k raised to 1 by 3. And it is provided that 8k square is equal to 1. So from there we can find the value of k, and if you substitute the value of k here, we will get the numerical value of the points. Okay, but let the points be a k raised to 2 by 3 and k raised to 1 by 3. Last we will find the value of k. Okay, at the last section of this answer, k raised to 2 by 3, k raised to 1 by 3. Let this be the point. Okay, now we'll differentiate and find the slope of this curve and this curve. So dy by dx equal to, so we can't get dy by dx directly, we have to differentiate this. This is implicit function. So derivative of x, which is 1 is equal to 2y dy by dx, or we can say dy by dx equal to 1 by 2y. The slope is equal to, let us write it as m1, the slope of first tangent. So m1 is equal to 1 by 2 into y, which is equal to k raised to 1 by 3. Okay. Okay. So m1 is equal to 1 by 2 k raised to 1 by 3. This is slope of first line, slope of tangent line to this curve. Now xy equal to k means y is equal to k by x. Okay, so dy by dx, here dy by dx will be equal to minus k by x square. Therefore m2 is equal to, okay, m2 is equal to, substituting the value of x at this point, we will get minus k by x square means k raised to 2 by 3 whole square means minus k by k raised to 4 by 3. This is m1 and m2. We need to prove that m1 into m2 is equal to -1 in order to prove these lines are perpendicular. So m1 into m2 is equal to 1 by 2 k raised to 1 by 3 into minus k by k raised to 4 by 3. Okay, let us simplify this, and at last we will give the value, we'll find the value of k from here and substitute here. Okay. So 1 by 2 into k raised to 1 by 3, k raised to 4 by 3. Okay, negative 1 by 2 into. So this is negative 1 by 2 into k raised to 1 into k raised to 1 by 3, k raised to 4 by 3. So k raised to 1 minus 1 by 3 minus 4 by 3. Right? Okay. This is k raised to 1, k raised to 1 by 3, k raised to, let us simplify this as k raised to 1 minus 1 by 3 minus 4 by 3. Since minus 1 by 3 minus 4 by 3 is minus 5 by 3, k raised to 1 minus 5 by 3, which is equal to k raised to minus 2 by 3. Okay, so k raised to minus 2 by 3 means it is in the denominator. K raised to 2 by 3. The power is negative, that's why it is in the denominator. K raised to 2 by 3. Okay. Now 8k square equal to 1 means k square is equal to 1 by 8, or k is equal to square root of 1 by 8. 1 by 8 raised to 1 by 2. Minus 1 by 2 into value of k is 1 by 8 raised to 1 by 2. So 1 by 8 raised to 1 by 2 raised to 2 by 3. Okay. Since we have to multiply the powers, then 2 and 2 will be cancelled. So 1 by 3 minus 1 by 2 raised to 1 by 8 raised to 1 by 3. Minus 1 by 2 into 1 by 8 raised to 1 by 3 means cube root of 1 by 8, which is 1 by 2. Cancelling this 2, what remains is negative 1. That means product of the slope m1 into m2 is equal to negative 1. Since product of the slope is negative 1, tangents are parallel to each other. Okay. Let's move to the next question. I think this much is enough for today. You have to do the rest of the questions in NCERT. Okay. And first of all, so what all things we have learned in today's class? We can find the slope. If the point and equation of curve is given, we will differentiate and substitute the point. Then we will find the slope, and we can find the point. If the slope is given, what we do is differentiate and substitute slope at the place of dy by dx. Solve it to find the point. Okay. And if you found point and slope, we can find the equation of line by point slope form. Like if I find slope and point, you can find the equation of the tangent by point slope form, and the equation of normal, which will be equal to negative reciprocal of the equation of tangent. Okay. Then only two concepts are remaining in this topic: approximations and maximum minima. And the questions of 6 marks comes from maximum minima. Okay. Then we'll meet in the next class.